Well, thank you for joining me on exercise 2A, question 7. Use calculus techniques to determine the exact coordinates of any stationary points of the following curves and use the second derivative test to determine whether maximum, minimum or horizontal inflections. So I've got this equation y equals x plus, and you've got 4 over x plus 3. And so I'm just going to get this ready for derivative. It's going to be 4 times x plus 3 to the negative 1. And we find the stationary points by letting dy dx equals 0. So the derivative dy dx will be, the derivative of x is 1. And now the derivative of this is the bracket 4 times negative 1 is negative 4. X plus 3 to the negative 2. You drop that down by 1. Multiplying it by the derivative of the bracket, which is simply 1. So we've got 0 equals 1 minus 4 over x plus 3 squared. There's our derivative. I'll take the negative across to be positive, so it's 4 over x plus 3 squared equals 1. I will take that denominator x plus 3 across to be multiplied by 1. We'll expand this and we get, or in fact we won't, let's just take that 4 across to be 0 equals x plus 3 squared and minus 4. Alright, now we solve this. Oh, we didn't need to take that 4 across because we're going to put it back. Okay, so we want to solve this. We take the square across to be plus and minus the square root of 4, x plus 3. Now we've got that 3 comes across to be negative 3, plus and minus, and the square root of 4 is 2. So therefore the two values are negative 3 minus 3, so negative 5. Or negative 3 plus 3, x is negative 1. So there are two stationary points when x is negative 1 and when x is negative 5. Let's get the y value for x is negative 5 by substituting into our y value, which was x plus 4 over x plus 3. So we put a negative 5 in there. So negative 5 plus 4 over negative 5 plus 3. So that's 4 over negative 2. So negative 2, take away 5, so we got negative 7. So there's one stationary point. We substitute the other stationary point by substituting negative 1. So negative 1 plus 4 over negative 1 plus 3. So it's negative 1 plus 4 over 2. So it's 2, and negative 1 is 1. So therefore at negative 1, 1, there's a stationary point. Now, what we have to do is we have to test these in the second derivative. So test in the second derivative. Oh, well, where was the first derivative? First derivative was 1 minus. Okay, so the first derivative, by the way, I'll just say dy dx was 1 minus 4 over x plus 3 squared. I'm going to get that ready to derive. I'm going to take that x plus 3 to the negative 2. Alright, now we can do t2i dx squared is, the derivative 1 is 0. Now 4 times, that's positive 8, x plus 3, and we drop that down to negative 3. And we times by the derivative of the bracket, which is simply 1. So we've got 8 over x plus 3 cubed. And that's the second derivative. So substitute negative 5 first. And what do we get? We get 8 over negative 5 plus 3 cubed, we get a negative 2 cubed, 8 over negative 2 cubed. So we get a negative 1. Negative means it's concave down, therefore it's a maximum at negative 5, negative 7. Substitute negative 1, 8 over negative 1 plus 3 cubed. 8 over 2 cubed is positive 1. It's a positive, therefore it's concave up, and concave up indicates a minimum at negative 1, 1. And we finished. We've got our minimum at negative 1, 1. We've got a maximum at negative 5, 7. Whoa, I hope this has helped. It was a good question. Stay happy. By the way, I suggest you graph these in GeoGebra. If you go to geogebra.org and graph this, there is a classic online that you could graph it in and see if these, if your maths is backed up by the graph.